All right, so welcome to class number 7. I think it's class number 7. All right, and wherever you are in time and space, it's wonderful to share all of this delicious information. We're going to be looking at the number 9 tonight, and the Enneagram, and the undercover construct, the invisible construct based on the number 9. There is so much synchronicity and alignments and curiosity with this number, and how it's woven into everything. And we're going to just hint at the secrets of the universe, so to speak, through the lens of the number 9. And honestly, this is such a basic overview, and hopefully it inspires you to go look a little bit more down the rabbit hole, but it's a really deep one. So we're going to look at a little bit of information, and then we're going to draw we're going to draw a nonagon, the actual polygon frame. We're going to draw 1, 2, 3 different Enneagrams. 2 of them will be closed, and we know that from last time, where we start and stop at the same point. And then 1 of them will be open, where we're looking at the fact that there's 3 equilateral triangles in the number 9. And we're going to start with Tesla's famous quote, if you want to know the secrets of the universe, look into the numbers 3, 6, and 9. So fascinating stuff today. I want to do a little drop-in meditation, and then we'll do a little check-in about drawing and how the week was, and then we'll get into the meaty stuff. All right, so let's take a minute. Let's take some nice deep breaths together. I want to invite you to close your eyes and bring your attention inward, and begin to take some nice, slow, deep breaths. Perhaps in through your nose and out through your mouth, just releasing the day. And with each breath, just bringing your awareness to this moment in time. Breathing some space into a sense of presence. With every breath, noticing, taking a little inventory of how you are showing up. Breathing into your body and feeling the surface of the chair supporting you. And with each breath, simultaneously activating your system and relaxing and releasing on the exhale. Maybe gently stacking your spine and opening your lungs into an energy of receptivity and alert awareness, with presence and the conscious connection to our entire system, noticing how you're showing up in your mental body, your emotional body, psychic, spiritual, energetic, all of the parts of you. Breathe into the all that is, bringing it all here with every breath. Remembering who we are, who we fully are, and taking a deep breath into your heart to connect with all the aspects, seen and unseen, that are here, supporting us in our expansion. And leaving a moment of deep thank yous to all the forces that have brought us here today, and for showing up. Deep gratitude for showing up. And as you're ready, back into visual awareness. And let's do a little check-in, a little hello. Roberta, how you doing? How was this week? Did you either draw or observe any new patterns with the geometry emerging in your consciousness?
No, not in my conscious, not in my third eye awareness, which was
Hmm.
happening when we first started the course.
Hmm.
But I was drawn rather than drawing because of my schedule. I was drawn to view, particularly from some of the slides that you had in the last class.
Uh-huh.
I gotta go find that, you know. So I was looking at a lot of sacred geometry,
Hmm.
pictures of, and people's interpretation, beautiful, beautiful artwork and things like that.
Hmm.
So that was for me almost more sustaining than actually doing the drawing this week. So,
Oh yeah. Sometimes it's like that.
mhm.
Um, and that's beautiful that it went that way, because it's all sorts of ways, right? It's observation, it's uh, reflection, inspiration, and it's just making those connections, that it's like it doesn't matter what it looks like, it doesn't have to be drawing. It's just this like integration of the information showing up in different ways. And I think reflecting the expansion. Yeah.
Definitely. And clicking on some of the links that you had for the music. So
Yeah.
I was super excited to see um, the sound frequencies
Hmm.
depicted in the what's that word? Somatic.
Uh-huh.
This,
This all the cymatics. Yeah.
yeah. So I was looking at a lot of the somatics and the ones of the planets. It turns out that my connection as a soul to the central sun,
Oh,
is the image that I see in my third eye, which I was not able to find anywhere before you presented it in your slideshow last time.
wow. That seems fairly significant.
So I got a lot out of following the rabbit holes, and that felt good.
Oh, nice. Um, uh, yeah, I mean, am I understanding right that that's fairly remarkable? I mean,
Uh, yeah, for me, I guess it's kind of it just reinforces everything for me. So that's
yeah,
cool. Yeah.
yeah, that seems, I wonder, I would think, there's a maybe they would have it, maybe not. There's a YouTube channel called Theta Realms. I'll send it in the email. They just have, like, I'm going to use the word oodles, right? Like so many frequency videos. And they might have one that's based in the sun, like
Mm,
that frequency, or you might be
mhm.
able to find it. Like if I don't know what the hertz was for the sun, but if you just plug in the hertz, you could probably find uh something really cool.
Right. No, this was all about sound for me this week in geometry because I also listened to many speakers on the Global Sound Conference,
Hmm.
and so I was doing a lot of toning and things like that that I don't normally do.
Oh yeah.
It was really cool.
Yeah, vibration in our bodies, we're electromagnetic. Like there's just all of the new tech that's coming out. All of like we're, if you're tapped in, we're just moving from like the kind of brutal, um oh, that's a strong word. Um uh okay, I'll just go with it anyway. Like the medical approach of disfiguration,
Hmm.
that means intrusion into the body somehow or whatever, influencing with different, elements. Um, from that, kind of tradition and perspective into like frequency and light and sound, because our bodies just resonate. So that's the easy way,
Yeah.
like pulse electromagnetic frequencies and all of the Royal Rife tech and all of the light beds and the sonic pulsing. And that's what we do here in Sedona. So yeah,
Yeah.
yeah.
You definitely need to make a trip back.
Oh, it's so good. It's so good. I'm so
Yeah.
grateful to be here. Um, So I want to, will you keep an eye on time,
Hmm.
because I want to make sure we get to everything. And um, if nothing else, if we have to end and I have to, keep the recording going for others, we'll work it out.
Yeah.
Um, but I know you have a time constriction. And um, I'm so excited. If sonic, if it was all sound for you, we're going to look at the geometry of sound. And I'm really hoping that the video comes through, because the last time we couldn't hear the tones. So
Right.
we're going to watch it's like a 12-minute video. It's called Sonic Geometry. And
Mm.
it's going to break down how each of the geometries have their own tone, and how that all relates to sound frequencies and chords and notes and scales and all of this. Yeah.
Very cool. Very cool.
So we'll watch that. The beginning is a man talking, but I'm going to get my speaker in case we run into that again. So then maybe we could do it that way. But what I want to pause is when they start playing the tones. I want to make sure you can hear them. Okay.
Yep.
So we'll do this. Then we'll look at a little bit of information of nines, and then we'll just do some drawing. All right.
Okay. Great.
All right. Here we go. I want this one. Close that out. I'm going to open this up. Make this nice and big. This is Eric Rankin, and there's about 4 of these series, and this is kind of the basic overview of the geometry. Super cool dude. I did some interviews with him and hung out with him at a conference, and he's been doing this for a long time, and it just makes so much sense, and it helps so much. And we're only going to watch the first 12 minutes, but I will send the whole video so you can follow up, because it really goes down the rabbit hole, but we just can't do that in this class yet. It's a little bit too much to go all the way, and we've got some drawing to do. All right, here we go. Let's see how this works. Also, just if I see you wave your hand, I'll know it's not working, but otherwise we'll just go ahead. Can you hear him talking?
No, I heard his voice briefly, and it was all chopped up.
Hang on, let's try this.
This language, or at least the foundation.
Do you hear him better?
Already exists.
Okay, I'm going to start it from the back. And then tell me if it's super like slurry. That's the other thing, okay?
It's said that if there is ever to be such a thing as a true universal language, it will most likely be expressed in the realms of mathematics, geometry, energy patterns, and frequency. Could it be that this language, or at least the foundation of it, already exists here on Earth? Is it possible that over the course of thousands of years, we have been somehow guided in the process of creating this new form of communication? And if so, what type of information will be conveyed through it that could not be expressed any other way? In the search for answers, we must be prepared to trek through both time and space, to open our eyes and minds wide enough to notice compelling coincidences, and to stand back far enough to see if the building blocks of some kind of mathematical, spatial, frequency-based language emerge. But before we begin our journey, we will pause here in the present day to notice some of the ways that we measure and tabulate the world around us. This is an important step, for how we count and measure things can be as revealing as why we count them. First, we will take a look at the way we measure time. For all practical purposes, the smallest unit is 1 second, and we all know it takes 60 seconds to make a minute, and then 60 of these minutes to make an hour. This hour, of course, is the unit by which we divide our days, and these days become months, years, decades, centuries, and so on. Speaking of 60, let's take a moment to notice that all geometry, whether it is 2 or 3 dimensional, is also derived from base 60 mathematics that provide the foundation for a 360-degree circle, which in turn provides us with all the angles and formulas for creating virtually every shape known to humankind. Now let's look at how many cultures from all over the world have chosen to count and group things. Right away, we see that we have been attracted to the number 12, 12 eggs in a dozen, 12 months in a year, 12 inches in a foot, 12 signs of the zodiac. Strangely, whether it's tallying disciples or mythical gods, the number 12 appears often in the telling of our greatest stories about ourselves. And what about distance? Your local town might be measured in meters or other units, but when we talk about measuring our planet, The standards we all use revert back to base 60 units of miles, minutes, or geometrical degrees. Are you noticing the pattern here? We seem to be encountering a lot of 12s and 60s. Are they related? And if so, how? To answer that piece of the puzzle, we must travel roughly 5,000 years back in time to visit the ancient Sumerian culture of Mesopotamia. For here is where our 1260-based math comes from. This counting system, which was invented by the same people who produced the world's first written language, involved counting the knuckles of the 4 long fingers on one hand and then multiplying them by all 5 digits on the other hand. If you do this, you will get a maximum number of 12 knuckles times 5 fingers, which of course totals 60. How these cosmic jumps in language and mathematics occurred so suddenly is open to debate, but it is interesting to note that the ancient Sumerians themselves wrote about being given this information by sky god visitors they called the Anunnaki. Who and what the Anunnaki were is a hotly contested subject, but one thing that cannot be denied is the fact that over 5,000 years ago, a mathematical system was born that incredibly still serves us today. So now that we have our various units of measurement, all based on the Sumerian 1260 counting system, let's jump forward to a few pivotal moments in history and see what other numbers, patterns, and synchronicities appear. In the 6th century BC, on the Greek island of Samos, the famed mathematician Pythagoras led a school of thought that married philosophy, mathematics, music, and of course geometry. And while Pythagoras did not discover advanced geometry, he did apply it in new ways, especially to music. For instance, he noticed that when a tauten string was plucked, it would create a tone. And when that string was divided in half, it would make the same tone only twice as high in pitch. Pythagoras then came up with numerical ratios based on harmonic fifths, and this led to the creation of the musical scale found at the root of most modern music. It is important to note that according to Pythagoras, all musical notes were found by using mathematics, and as such were given number values according to their placement in a kind of master grid. For instance, by using fifths beginning from note number 1, he was eventually guided to note 27. And to find the same note twice as high in pitch, he simply kept doubling it to 54, 108, 216, 432, and so on up the scale. If you've ever heard of Pythagorean tuning, you know that the number 432 is quite important. To Pythagoras himself, it probably wouldn't have stood out more than any other in his numerical grid. But in our quest to find a universal language based on mathematics and frequency, this particular note represents a significant piece of coincidental evidence. You see, many ancient musical instruments, from Tibetan bowls to Native American flutes, happen to produce the same tone, a tone that vibrates at 432 cycles per second. That's compelling, but even more intriguing is the fact that Pythagoras was not calculating vibration cycles to find tone 432. It just happens to be the same number. What's more, for decades, most modern musical instruments were also tuned to this same 4th octave A, with a value of 432 cycles. How could this be? Who chose this particular note as the keystone for instrument tuning? And more importantly, why? Here is where a deeper mystery begins to emerge. And to explore it, we will need to go back to Pythagoras' other passion, geometry. It is not an exaggeration to say that to Pythagoras and his disciples, geometry and math held a key to the nature of all life everywhere, and maybe it does. Let's look at the first 4 geometric shapes, the circle, triangle, square, and pentagon. In each of them are angles of degrees that, when added together, always total a specific number relative to that particular shape. For instance, if we take a triangle, the sum total of all 3 interior angles is always 180. For both the square and circle, it is 360. For a pentagon, it is 540. Now at this moment, let's step back and look at these numbers in a different way, as there seems to be something about them that reaches beyond a simple sum of angles. Did you notice that they happen to be in the same numerical neighborhood as tone 432? What's more, they all add up to 9, just like 432. As an experiment, let's take a look at the numbers found in basic geometric shapes, then apply those numbers as vibration cycles to hear the tones they produce. First, let's listen to what the 180 total degrees contained in a triangle sound like.
That one's really low. Could you hear it at all? Oh, no, wait.
tell me what you could hear. Can't hear it? Okay. Let me try one of the higher ones because they get higher pitch. We'll try the next one and then we'll figure another thing out.
And here's a squares and circles 360 in cycles per second.
Nope.
A perfect octave up from.
Okay. I never used to have this problem, so I'm really frustrated. Let's see if we can do it this way. This is going to go out the computer and back in on your audio, so I don't know how this is going to go. Can you hear me right now? Okay.
Yes.
All right, let's see how this goes. I'm going to back up for a second.
Relative to that particular shape. For instance, if we take a triangle, the sum total of all three interior angles is always 180.
You can hear him? Okay. So then give me a thumbs up if you can hear the tone, right? Okay.
For both the square and circle, it is 360. For a pentagon, it is 540. Now at this moment, let's step back and look at these numbers in a different way, as there seems to be something about them that reaches beyond a simple sum of angles. Did you notice that they happen to be in the same numerical neighborhood as tone 432? What's more, they all add up to 9, just like 432. As an experiment, let's take a look at the numbers found in basic geometric shapes, then apply those numbers as vibration cycles to hear the tones they produce. First, let's listen to what the 180 total degrees contained in a triangle sound like. And here's a squares and circles 360 in cycles per second. A perfect octave up from the triangle.
Okay.
What about the pentagon at 540?
That one?
That sounds like a harmonic fifth of the other.
That is just so frustrating. Okay. That never used to happen. So what we're gonna do is we're just gonna watch it without the tones, which is a real bummer. But basically, and then I'll send it to you, and then you can play it and get the tones. But basically, he's putting together the geometries and seeing that the tones and the chords make perfect major chords.
That'd be nice. Yeah.
So it is. I don't know what happens because you get the rest of the video. I don't know why you don't get the tones now. So I'm sorry, but we'll just do the best we can and I'll send it to you.
Okay.
That's interesting. What are these tones? They are F sharp and its perfect harmonic fifth of C sharp. Let's keep going. What does a hexagon 720 sound like? Another F sharp. Here's a 7-sided septagon, which totals 900. This is an A sharp, which happens to be the note required to complete an F sharp major chord in perfect 3-part harmony. And finally, the octagon, where we get 1080, another C sharp. Suddenly, geometry is expressed by tones, and these tones just happen to create the most beautiful form of music, a perfect 3-part major chord in the key of F sharp. Is this something we've been missing for years? Is it important? To the famous philosopher and mathematician Plato, the answer would have been a resounding yes, for it is Plato who advanced the study of 2-dimensional geometry into 3-dimensional geometry, and who began to recognize that nature, whether expressed as a tone, the petal design of a flower, or the spiraling design of a seashell, seemed to follow a 3D mathematical pattern. In fact, it became an obsession of Plato to try and find the simplest 3-dimensional geometric shapes, and his quest ultimately revealed what we now call the Platonic solids. In essence, these forms represent the most elemental construction blocks found both in human-made and natural forms. So let's see if and how they fit into our geometry tone grid. First, there is the tetrahedron, or a 3-sided pyramid comprised of 4 interlocking triangles. As we did before, Let's add up all the angles found in those four triangles. The answer, 720, which we have already seen is the tone F sharp. Next, we have the cube, whose 6 360-degree squares totals 2160. What does it sound like?
We don't get to know.
2160 is a high C sharp, and as you will see later, a very interesting number for other reasons as well. Next up is the octahedron. Constructed of 8 triangles, this shape totals 1440, which is another perfect F sharp higher up the scale. The icosahedron is made up of 20 triangles, so the total number of degrees is 3600. As a tone, 3600 vibration cycles create the A sharp needed to complete yet another F sharp major chord that sounds like this.
Sounds really pretty.
At this point, we have seen how 2- and 3-dimensional geometry can be expressed by the notes found in an F sharp major chord. Could this also be true with what is known as sacred geometry? To find out, we will first need to build a design called the germ of life, which, when repeated, goes on to reveal the seed of life, then flower of life pattern found at sacred sites all over the world. First, we start with a circle at 360 degrees, which is the familiar F sharp. We then add our second circle, bringing the total to 720, another F sharp. 3 circles totals 1080, which provides the harmonic fifth of C sharp. 4 circles is 1440, another F sharp. 5 circles totals 1800, or the A sharp needed to once again provide the harmonic third of an F sharp major chord. And finally, the 6th circle, which brings the total to 2160, another C sharp. Amazing. It's as if we can now both see and hear the flower of life pattern that has intrigued humankind for thousands of years. So now we have 2-dimensional geometry, 3-dimensional geometry, and even sacred geometry being represented by different variations of an F sharp major chord. How is this not common knowledge? How have we missed this connection? There are actually 3 explanations. 1, for reasons ranging from the mundane to the conspiratorial, musical instruments are no longer tuned to an A vibrating at 432 cycles per second, but rather 440. 2, modern tuning calls for equal temperament, which no longer adheres to Pythagoras' whole number simplicity. And 3, the tuning method required to reveal geometric shapes is based on a mathematical grid rather than mathematical ratios. This grid, if it had a name, would probably be called something like factor 9, because the number 9 is found not only in the sum of every note on the grid, but also as the number required to move up or down the scale. For instance, if we started at note A at 216 cycles, all we would have to do is add or subtract the number 9 to reveal all the other tones in that octave. And it is here, on this incredible factor 9 grid, that we find not just some of our geometric numbers, but all of them.
All of them.
Conversely, modern A440 tuning reveals not one correlation to geometric numbers.
Mm-hmm.
Now let's go back for a moment and take a look at one of these numbers, 2160.
All right. So the rest of the video is about 2160 and sort of a more conspiratorial, not conspiratorial, but like looking at the obvious things of like, why is this not common knowledge, right? I'm so sorry for the video. Honestly, I've been teaching this for a long, long time, and that has never been happening with the video. So what I'll do is I'll just put a little note in the email, and I'll say, watch this first. Yeah, so frustrating. Were you able to hear any of the tones?
On occasion, there would be this quick, sharp pitch. But I find it curious that F sharp is like so incredibly difficult of a key
Is it?
to play, and it's the worst.
Wow.
Yeah.
I know nothing about music, and I want to know. And if
Yeah.
you look into F sharp, it's even more of a rabbit hole than the number 9. It's
Yeah.
but
Yeah. It's
that's
like
interesting. What makes it hard?
playing only the black keys on the piano, essentially.
Okay.
Yeah. So it's interesting.
Very
Huh. I have a program that allows me to see the hertz, when I play a note.
Mhm.
So I'm going to play around with that for a little bit. I don't know what I'm doing, but it just popped into my head. So
That's the best way when we don't know what we're doing.
yeah.
Okay, great. I didn't know that about F sharp. That's fun. I from the other class the other day, I feel illiterate in music. I
Mm.
don't understand it. And so I was like, I'm going to take a music theory course. I just need to do that because just to understand a little bit more because the geometry is so fundamentally related to that.
Yeah.
So, okay, so we'll look at just a little bit more information and then we'll get into drawing them. Here we go. Bring this up. So, I again am like just learning about the potency, right? So you've got in here you can see there's are there the different so there's the red triangle, there's the green triangle, and the blue triangle. The blue one you lose the bottom left angle, but what these numbers touch on is you can see 3, 6, and 9 are one of the triangles. 1, 7, and 4 is another one, and then 8, 2, and 5 are just as important, right? So we can look at 3, 6, and 9, but if you start to divide space with the number 9, you're going to start to find some amazing synchronicities. I can't stand it how Eric uses the word coincidence because there's just no, like, that does not include a higher orchestration, when you use that word. So if you're looking at the blue triangle of 1, 4, and 7, that adds up to 12, which is then 3. If you're looking at the green triangle of 2, 5, and 8, that adds up to 15, which is 6. And then 3, 6, and 9, 18, which reduces to 9. And this is just one very, very small example of the mathematics and the number sequences that start to suggest that we clue into the fact that there is way more going on. And like, I can't even begin to scratch the surface, honestly. But, he looked at the larger measurements, right? Times days in a year. This is an example of how you can break down time to find the nines woven everywhere into the number sequences, right? And I think this is part of the way of how we could kind of manipulate time a little bit, right? Is to start to break it down and understand the number sequences and understand that there is a mathematical sequence. It's not just like an arbitrary governing, imprisoning construct. It's like we could have the keys when he says unlocking the keys to the universe, like it literally can give us the keys to, sort of bust out of these limiting constructs. But there's just so many cool number sequences when you start to look and break down the number 9. And I love how it just reduces into itself again and again and again. So there's like this fractal nature of it as well. And this is the number 9 grid, that factor 9 grid, just to revisit that. Like all of the tones, all of the internal angles of all of those geometries that he looked at, they are all on this grid, right? And then if you look at a 440 grid, like he was saying, none of the numbers are here. And so someone was asking me, or we were talking about, like, maybe 440 is just the more natural expression of sound. And I was like, well, no, because there's no harmonics, there's no number sequence relatedness. And so you can see here on the left, working with the overtones and the harmonics, there's no organizing pattern. But with the 432, you get the nines, you get, all of the sequences, this beautiful organized pattern. And so, we talked a little bit last time about 440 and how the frequencies have been distorted to manipulate and influence. And I think looking at the math of it just kind of supports that belief. So here was, part of the image that we saw. And, this is the tone in the medium of water. And if we think about ourselves as 70% water, like, it's just hugely impactful. And so that's part of why I bring cymatics into the course. And this is a tiny video that shows us how you can divide space by 3, 6, and 9. And there's no sound to this, but I think the video comes through. It might be a little choppy, but we're going to give this a try. It's tiny, tiny. And It's just showing us how you can divide fractally by 9 in and then out, and you get the same, kind of get the same God code. So we'll watch this for a second. Is the video working? Can you see it okay? All right, great. Yeah, you think. Right, so 720 is the tone of the hexagon, right? And then 1080 is the tone of the octagon, right? So it goes back to the sonic frequencies. And then 1260, right? That's an Enneagram. Got the decagon. I mean, between those two videos, it's just super cool, right? What do you think?
Definitely mind blowing. I had seen some of this before because I've been, like I mentioned in the very beginning, very attracted to numbers, and so some of it's familiar, but that whole "it is everything and no thing" that's new. That
Cool.
was, yeah, as far as the geometry, very cool.
All right, at least I've given you one new nugget. I know you've just been doing it for so long, but we'll do some drawing, and it's always good to just even if it's familiar information, like we're different, we're going to hear it in new ways. Find
Yeah.
little things here and there. I think there's just a little bit more info on that slideshow. I think I skipped ahead last time. So, nope, we're going to draw. So, so I think we're ready, right? Any thoughts, questions, pauses, any needs before we move on?
No.
Okay, great. So, here we go. So we're gonna start. You know how I like to do everything from the seed so that we can see that relationship, because we'll start with you can start with a radius that is 1.5 inches, I believe. 1.5 inches is going to stay on the page. And then you definitely want to measure to the center of the page on the vertical. So find that 5.5 inch point on the center. Because it is easy to go up high or too low on this
Oh boy. Okay.
Oh boy. Alright.
Eyesight at this hour is probably not that great. And you said 1.5 inches?
Yes. Are you a super morning person? And it's no, I mean, we're not going to have to reschedule at all. I mean, this was just anomalous for tonight.
Yeah. No, I'm an all day person, but I stay up too late.
Oh, yep. Me too.
It's just the darker it gets and the older I get, the less my eyeballs want to look at anything.
Yeah.
Okay, we're good.
Okay, 1.5 inches. You should get like a ring light that can make it bright on your drawing. Those are really helpful.
Yeah, I was thinking about that earlier.
Something, because my eyes can't do it either. So 1.5 inch radius, we got that. Now just go ahead and do your seed, an initial seed of life. And it's at the beginning of the class, like, however many weeks ago, it's just not possible to really grok that everything comes from this shape, right? Like everything. We'll see it next week too. We're going to do 264 star tetrahedron that start with seed. It's remarkable. And even though the seed and then the next round of circles are six-sided hexagonal constructs, right? We're going to break it down into 9. Right? So there's 3 rings, and then we're going to break it into 9. Let's find some symmetry.
So we'll be erasing a lot of these circles, right?
Well, no, because because of the template strategy that I did with the I think it was the heptagon, right, where we just puncture holes through to the next page, so we don't have to do those structures all over again. So
Okay.
this one, I used to ask everyone to erase this whole flower, but now we're just going to puncture through with this geometry as well. So you do not have to do that. Always learning new things.
Okay. Oh, I hate when I get lost. What the heck? I did that. Okay. Here we go. Last one.
All right.
Right.
This one.
Okay, so we have a flower.
All right. Well, it's just a seed at that point.
Seed, yeah.
So let me close this out because this isn't what we want. All right.
I'm being a little sketchy here.
Hold on. What's happening?
My pencil is not touching the paper in the same way each time, so
Why is that? What's happening with that?
I don't. Maybe they're not lined up. Maybe my angle's wrong. I don't know. Just make my lines prettier. Okay.
Is the pencil slipping up and down? Do you need to
It
rub
isn't.
around it?
It isn't. But I think it's
All
a
right.
little shorter.
Okay.
Go
We'll
ahead.
just keep going until we can't go anymore.
Okay.
Do we do anything differently? Or no?
What? I'll make you.
The compass. Do you need to find another one or anything?
No. I'm fine.
Okay. So we've got our seed, and now we're gonna just start at the bottom point. Start at this intersection down here, and we're just gonna do like we do for the flower of life. We're just gonna go around that initial seed, and we're gonna draw the next ring. I always recommend starting at that bottom point because it helps you see the hexagon unfold. But you don't ever want to stop and look at this shape, remember, because it looks really weird until you get all the way around to the bottom.
Yeah, I'm not sure I got the hexagon last time. I had a lopsided something. Confused
Well,
me.
the fun thing is even if you have a lopsided something, we will get the shape we need today.
Okay.
I think that's the fun thing anyway.
I just hope I'm on the right vector to begin with. Nope. Okay.
My guess is that you are. By this time, we have enough familiarity, and the pattern that I find the most with you and with others is that you think you're off, but you're actually on.
Okay.
All right.
I see a little glitch in the force here, but that's okay.
Okay.
Couple lines aren't meeting up.
Well,
Too pretty.
Yep. That happens. It's true. And are you doing the step where you like actually change your grip on the compass? Have we talked about that?
No, you talked about fudging the lines every now and again if they didn't match up.
Yeah, you can do that. Here's what I mean. So instead of, I don't have a pencil on this one. So when you do your circle, and then instead of going like, okay, it's here, go ahead and do your circle, and then change your grip and put it down.
Yeah, I always do that.
I thought we talked about that because that
Yeah.
helps precision. But
Yeah.
it just takes practice. I don't think you've done another flower since we did it. So,
Just one a long time ago. 6 weeks is a long time.
a long time. Very long time. We are going to go all the way up until Thanksgiving. We're going to go past Thanksgiving, which is just amazing to me.
Yeah, wasn't it like the first week of December it ends?
Yeah.
Okay. That one's so messed up. Okay. All right. We're good. Don't worry about it. All right. So I'm ending on this last one before the one I started on.
Yes, exactly. We should be on the very bottom point.
Okay. Everybody in there? And I'll look at you.
Okay. Okay, hang on a second. We need one at the very top point, at that last little full divot, and then you'll be finished. Or is it the bottom? Is that one the bottom?
It is the bottom for me, yeah.
Okay.
I always turn it up.
Meow
Yeah, I fed him in time, so that's not. Yeah, I was pretty sure I hadn't made it back around to the, but that's where I started. So now it's fine.
Okay. Pull it back just a little bit more. Yeah, you're just on an angle. Your shape is oriented. Your vertical is like at 1 o'clock and 7 o'clock, which is fine, but we want to make sure that's your vertical. So
Okay.
all that means is that you didn't start the second circle at the very bottom vertical. You just started it a little bit to the left. And so that whole shape orients a little bit.
No.
Got to be right in there.
Get your butt out of the screen. Come on. No.
Yeah. Oh my, so handsome.
He's very handsome, yes. And so annoying. He'll be back. Don't worry.
No, all right. I won't. What's his name again?
That's Spirit.
Spirit. All right. So that looks beautiful, by the way. You're so sort of the grimaces you're going, oh no, but it looks solid. It looks great.
Yeah, it looks solid.
Okay. So here we go. Next bit. We've got our flower, right? That's the first ring. If you want to go for the full expression, you need to have 2 more rings around that as well, if you remember. So now what we're going to do is we're going to open the compass it'll be about 3 inches wide. But you want to open from the center point to like one of the hexagonal, like the extensions, right? One of the 6 points that go around the shape. And then what you can do is open it to the 3 inches, measure it to the perimeter, and then kind of tap all 6 of the points, right? Tap all 6, see if it's fairly equidistant, so like that the line brushes the perimeter of all the other 6 outer points. And then you can just adjust the compass point a little bit if it's, if there's a mismatch, and then just find your way so that the circle is fairly equally hitting all 6 points. It does not have to be precise at all. This is more along the lines again of like fudging a little bit to get some of the symmetry.
So it comes to 5 inches?
Should be about 3, but I can't remember the measurement.
Definitely. So the center, to the outer.
Yeah.
Outer ring, yeah, that's what I'm doing, and it comes to 5. So how'd that? Okay. So I want every point that's where?
All 6 points, like all 6 of these outer, like if you were to bisect the shapes, like these 6 furthest out points, right? So that the compass goes around in a circle and touches those 6 points equally, right? It's going to look like this.
Yeah.
Yeah. So
good luck with that. Yeah, okay. That's not happening. Something ain't right.
Yeah, just approximate.
Yeah, I'm making one big circle around the whole thing, but that's not correct.
Yes, just like this.
Maybe, maybe not. Okay. Some spots, yes.
Okay, yeah, it doesn't, it's sort of, you can adjust the compass point, touch all the points and see, you know, just jiggle it a little bit, and some will go over and some will go under, and it's really actually for this shape does not matter at all, honestly.
Okay, just trying to hit a couple of those circles.
Oh, hang on, let me come out. Hang on.
Okay,
Oh, yeah, perfect.
all right.
Yeah.
Here's lower where you can see.
Looks-
Beautiful.
Okay,
Next.
well done. So now what we're gonna do is we're gonna divide it all up into 9. Okay.
Okay.
So we do some letters first. All right. So we're gonna letter the points as shown here. All right. So, and you do it kind of nice and light because you want to be able to erase them even though you don't erase the flower. It's just fun to be able to. I can't. Hang on. I'm gonna come out of my screen share because I can't get there we go. Okay. So A is in the center. And then G is up top at the intersection of the top petal where that ends. G is up top. And then if you go all the way on the bottom vertical, that's up here. Sorry, not all the way to the vertical. Stopping just shy. It's the center point of this inner circle is F, right? Each of them is going to be the center point of a circle, right? So you've got
Good. Now I know what you mean about me being a little cockeyed.
Yeah.
Yeah, not lining up the way yours are, but okay.
Right? Well, usually just be on a slight tilt. You could pivot your paper and get it totally, vertical like this one, and it'll look a little easier.
Oh boy, I'm gonna be lucky if I hit any of the right ones.
You will.
C. B's over there. Yeah, maybe. The center of the petals. Center of the petals.
It might be easier for you to just pivot your paper so that it lines up. Because you could do that and then it'd just be on the vertical.
I'm not even understanding that, but it is late. So here we go. D.
Yep, so your flower tilts to the right.
Yes, it does.
Okay, so pivot your paper to the left, and then it should line up on the vertical.
So my F is in the wrong spot.
Mm-hmm.
Okay, A, G, F. Let's check out the E's and the D's. Yes, and the, oops. That's not
C,
looking
C,
right.
come on.
Yeah, they don't look like they're doing the same thing as E. Maybe the B's over here. Okay. Mm-hmm. C. Yeah, that looks more symmetrical. But maybe C goes over here. Yeah. Yeah. Maybe. Wow, I think I'm missing a petal on that one.
Okay,
Well,
let me see. No, I don't think you are. Let me see.
no, well, I think my C is in the wrong place. My B might be now too. Can you even see the letters?
Yeah. So G's at the top, D. Okay. No, you're in the right place. You've got the B, and I think you just need the C, which is right across from it. Yeah.
Yeah, but mine doesn't end up being in the same place.
Give it a chance. I think it will. I mean, from what I can see, you've got it.
Well, C is over here.
Which one is that?
C.
Yeah, and then right across from it is B, right?
Yeah, over there.
Yeah, you've got it. And then
the rest of them look proper.
okay, let me show me one more time because it is okay. So tilt your go the other way. Go the other way. There you go. Yeah. So B, C, G, you've got them all. Yeah,
okay.
for sure.
Okay,
so,
good.
You have F, which is right here in the center.
Mm-hmm.
See that one.
Okay.
Okay. All right. You ready for the next one?
Hardly. Go ahead.
All right. Here we go.
No.
So we're going to bisect, right? Well, we're actually cutting into 3s. And so you're going to come on the top center vertical line. So starting at A and going up through G. Starting at A and going down through C. And starting at A and going down through B.
You just want the line to extend all the way to the outer circle.
Mhm.
All right, looking good. You're off mute though, or you're muted. Okay, so pivot it on the vertical, like align it to the vertical, other way, there. Okay, so your on your left side, is that C for you? Okay, your C wants to be down 1 point. Yeah, you got it. That one is a little off. I couldn't see it before that though, because we're breaking them up into equal sections. Yeah. Does that make sense where it's going to go?
Yeah, I'm muted because there's stirring going on in the other room, and
Okay.
it might be noisy for your
Okay.
video.
Okay, here, I'll put it back up. Here you go. So the B is kind of going to parallel. You've got B, F, and C. They're all on this same horizontal axis. They go right across from each other. So C is going to be, it's going to parallel. Or mirror, maybe? Yeah, when it gets dark, you know, when the dark days set in, I always want to be home at least before dark, and it just sets in that, you know, that mindset of like, okay, we're hibernating. Okay, hang on a second, let me. All right. Okay, don't move. So the your right hand, on your right hand, that line, did you just erase it? Because it where it was where it wanted to be actually. But hang on, let me just look, because it just, let me just see. I think it's because you're off kilter a little bit. So yeah, put it back where it was. I'm sorry. I think it's a little tricky. And you know what though? You're not going to need, you could actually just draw the line again. You don't even have to erase that line. We're not going to need the center of the shape. We just need the 9 points on the outside. So you could just redraw that line that was there before. Okay. All right. So we've got this segment here. All right. Now what we're going to do is we're going to work with D and E up here, and we're going to create a horizontal line. So it's going to look like this. All right. So just using D and E up above and extending the line all the way to the outer circle. What's happening? Okay. What should I do? Okay, hang on a second. Okay, so on your right hand, on your right side, you can see the line that you erased where I told you to erase, right? And then you put the line a little bit lower, right? Draw the line, draw that line that you erased again, because that was correct.
Normally, I'm a good student. I told you were going to see a different part of me.
Well, different part of me too. It's, you know, I appreciate the adjustment.
Okay,
All
we're
right.
back on track.
What on earth?
I know.
Wait, so did you draw? Okay, so these two parts are wonky. So you want to draw. Okay, so A, is it, tell me, is it B on your right side down there?
Yes.
Okay, so you want to go one petal up. So basically that's like 7:30, you want to go to 8 o'clock. So go just draw the line that you erased. Draw that one again, because that's the one we want. Right above it. We'll get it. Like I said, we don't need the inside of the shape at all. We're just getting the coordinates. We're getting the 9 points on the outside. You don't have to erase that bottom one at all.
I have to go. I get so confused.
Okay.
All right. So I'm putting the lines back in the way I have them.
Yep. I think it's the kilter.
Okay.
Is throwing us off.
All right. I don't like the heck whatever this is when you add. Yeah. Okay.
Perfect. You got it. All right. So we got that. All right, we're up to speed now. And looks like this. And then now we're going to we connected D and E. Now we're going to connect D and F. Right? We're going to go through those 2 points. So the line is going to be like that. So it'll be on the left diagonal going through F and D, and you want to extend it all the way to the perimeter. Yeah? Good. Okay. And then you're going to do the same thing through E and F on the right axis, right? The right diagonal. So now we have divided 6 segments, 6 sides. You know, a hexagon is 6-sided into 9. All right, you got that? Okay. So now what you want to do is puncture your holes. Puncture holes through those 9 points, right? Maybe darken them in, all of these external points, all 9 intersections of the dividing lines and the circle, and then puncture it through. You can do it nice and deep because we want 3 different pages with those 9 points. And you can repuncture as we go along, so it doesn't have to be like hugely significant, but you want to puncture through to the next page, and then we're going to go on to the next page. You don't have to erase anything. Puncture through those 9 points, and then on the next page we're going to label the numbers A down around clockwise up to I. You can do those nice and light because those you will want to erase, right? What's happening? You have them though. Yeah, okay. What do you got? Okay, so 9 points, right? So you punctured through to the next page?
Not yet because this I don't have the 9 points. If I put this point in, isn't that awfully close to itself? These two here?
Yes. Your okay. So okay. Those 2 lines are off, right? So the okay, okay. The point where you have the intersection point, right? You see that point? Put your finger on that point. Okay. Now go up 1 petal towards the center. So that point is the intersection point that you want. Yes. That is F. All right. So then the lines want to go through there. You can do it. We're almost there. I'll put it back up so you can see it. All right. You want it to look like this. And I'm sorry for the fact that I can't see it very well, and whatever the tilt is and whatever the angle, that I can't stop and go, no, this one. All right. So you want an equilateral triangle in the center. That's what we want to do. So you got the point where F is?
Mm-hmm.
Okay, so then on the diagonal, D through F and E through F. Well, we should look at the magic of the 9 here. Significant somehow. Everybody has different experiences with every single polygon. And I think that's a little fascinating on some level, but I don't know how. It's lining up better this time, I can tell.
Yeah.
Yep. All right.
Yeah.
9. Yeah, and then give it a solid puncture through. Usually you can make it through, 2 or 3 pieces of paper, but just whatever works. And you want to, on the next page, darken in those 9 points, and then nice and light, label them A and going clockwise all the way around to I. Did you say you have until 6:45 or 7:15, or do we need to end at 6:45?
And it's down, so we will end when we're done at this point. Okay, A, B, C, D. Hang on. Oh crap, where's the top of the, where's it? My top's not in the same place, so I'm starting here, A.
Right, because you're gonna be off kilter for the whole thing.
Yeah, isn't that pleasant?
Well, I wonder if there's, a reveal in that somewhere,
I have not been, I've been really rock solid, nice and even keeled, no frustrations, no stress, no whatever. I mean, tired, physically tired,
So
but
now,
been off kilter till just now. Just now.
all
Okay.
right. Well, then no reflection whatsoever. So, I mean, you might really want to just tilt your page so that we're on the vertical, together, because that might be part of the conundrum, right? Okay, so you've got A through I. Yep. Okay, great. So I think we're just starting with the nonagon first, right? This is the polygon boundary. Lines don't intersect with themselves. We're just connecting A through all the straight lines around back up. So that's also a closed geometry because you start at one point and you end at the same point. And we're going to see how it's super cool when all of them are overlaid on top of each other. It creates a really fun, its own fun geometry. Tell me when you got that. And I like this one too, because you can practice a little bit of precision, right? With using that technique of, put the pencil down, line up the ruler to that. And then you put the pencil on the other point and line up the ruler to that one, and then double check with the original point. Let me see. Yeah, beautiful. Nice. Love it. Okay. So we got that. So now, where's we do this? Okay. So we did the second one. I left the second one on this same page with the boundary, right? So we're not starting a fresh piece of paper, but we're going to do the next obtuse Enneagram, right? So this is one of the stars, which makes it a gram. It's it's a complex polygon when the lines cross over each other, and it's the star inside. And we're going to skip every other letter. So you're going to go A down to C, and then C down to E, and you're just going to go all the way around in this spinning motion. And we're going to do a fun fractalizing thing with this one. So tell me when you get back to the beginning. So it's all just the every other letter, creating a 9-fold Enneagram. It's an obtuse, right? It's that wide angle. Hang on a second. Oh, you got the, oh, it's so light. I can't see. Is there another ring? There should be another.
I haven't done the second one because I need to know where to start.
Okay, here you go. So it looks like you've got A to C and C to E. Do you have G up to I?
Yeah.
Okay, so then it's I over to B. Got that?
That's where I gotta go.
All right. And the PDF has this all sequenced, so you have the letters up there too, right? So it's I to B and then B to D. And you know what I think we're gonna do is because we've scrambled ourselves already. I think we're just gonna keep it. We'll keep it like this for a minute. We'll finish up with the other ones, and then we'll decide if we want to fractalize this one.
Okay.
All right. So you got them all D to F and back up to A. To get them all. All right. Let's just pause and take a breath with it. What do you think? What do you notice? What do you feel?
It feels good.
Mm-hmm.
I like all the triangles. I'm seeing all the ones that are similar and the ones that are different. Okay. Yep. And
So it's its own asymmetrical symmetry, right?
yeah, it's pleasant.
Yeah, pleasant. I'm pretty sure that in the last 2 classes we're doing the Sri Yantra, this thing, and this is 9 asymmetrical triangles. Don't worry about it right now. Don't look.
I better practice before the class.
All right, so we break it up in two classes. It's easy peasy. We just go like we have been the whole time, just one step at a time. So this is 9, but it's symmetrical, right? We've got 3 right angle triangles in there. So let's find that. So I think we're gonna puncture through. So puncture through all 9 points again and down to the next page, so that we get an open circle. And nice and lightly label, A through I again.
Because I keep flipping the page, I'm back on my task rack over here, so I'm gonna have to rip this page out to do this.
All right, can't have that.
I hope that works. I hope they line up. Or else, boy, that's gonna be messy.
Oh boy.
Just now. Oh dear. No. The hole here. Match it with that one. Wow. This paper's not even this. Okay.
All right.
Hang on a sec.
Oh, no problem.
Just want to make sure the holes are going in the same holes I already made.
That's a good idea. It'll be easier.
Yeah. Okay. Now the page is crooked. Okay. I'm all right. Okay. No, I'm not.
All right, that's here.
Oh my God! I just made this huge hole. Not my night.
Well, we're almost there. We'll take it nice and easy.
Oh yeah, but this isn't gonna work. I can tell you right now.
Okay.
I can't puncture the other holes without this being lined up.
Oh, okay.
Correct?
Yeah, I'm just gonna walk with you as you're figuring that out.
Go ahead.
Yeah.
Okay, we should probably stop here. Can I draw on this one instead? Because unless I redraw it on the next page.
Show me again what you just showed me. I can see it.
Okay, so can we do the next? Can we play with this instead? Because
Absolutely.
I cannot line up all those holes.
No problem. We can absolutely do that. You'll have all the shapes at once, which we get to down at the end, so it's fine. No problem.
Right.
All right, so we'll stay with this, right? We can go from here. All right, and we're gonna stay with A, B, C, D, all right, and we're gonna use those points again. So with this one, we skipped every other letter, right? And so we're gonna do the super pointy one. This is the acute, right? And so the letters are up here, right? You can refer back to these. So you want to start with A, and you're gonna go down to E. That'll be your first one. So A down to E.
Yep.
Okay, and then you're going to go E up to I. And it's going to create that same shape just from every point, right? So you'll see that skinny triangle. And then you're going to cross over and go I down to D. And this is another closed shape where we start at A and we end up at A. And then where are you at? You D over to H. Did you do that one? Okay. And then H over to C on the horizontal there. And then you're going to go C down to G. Tell me if I'm rushing you. I'm just trying to move with what I see you doing. And then G up to B. And then B down to F. Oh, wait. A, B, C, D, E, F. Yeah, B. I wrote that down. B. And then F up to A. I wrote that wrong up there. Sorry. So B, C to G, G to B, B to F. Because it looks like an I down there, so I'll fix that. So B to F and then F up to A. All right. Okay. All right. So, yes, beautiful. What do you think? We got 7, 7, 9, 9, and 9. Excellent. Okay. Oh, you're muted though. I can't hear you.
Getting cooler.
Okay, cooler. Now, this one will get complex if we add the last Enneagram. Are you up for adding 9 more lines? Or do you want to leave it like that?
No, it's
Okay,
good.
I'll show you what it's going to look like. So here's these. All right. And then you could do, if you play around, you can do the shapes independently. So we're going to draw this one, which is the 3 equilateral triangles. And we can walk through it, but it's going to look like, ultimately, it's going to look like this, which, if you remember, looks just like that 12-pointed star that we did. So you could either draw, you could either find points B, E, and H, back up to B and draw a triangle. Or the other way to do this, the other way, which we might just want to do, is you're going to connect, like we did with the original start, you're just going to connect every point to every point, right? So you could just start with the A, you've already got A to B, you've already got B to C. What you want, do you have B to C? Yeah. You would want B down to E would be the one that you need. And then E up to H. And I'll put these up. Well, I'll put it here because this is more like what you've got. And then you want H back up to B. So that's one of the triangles. So that's the equilateral triangle on the right, or the right axis. And then you did that all 3, and then you could start from I. And you would want I over to C. Let's see where that empty hole is. And then C down to F. and then F up to I. And then you could start up at A and go down to D. I don't think you have that one yet. And then D over to G. And then G up to A. So finishing that. But this is an open Enneagram, right? Because it doesn't start, you can't complete the whole design starting and stopping at the same point. So this is what it looks like isolated, right? But then you likely have this. So let's take a peek at what you got.
Cool.
Cool, right? There
Yeah,
you go.
I like this.
Yeah. What do you think?
I like it. I like it.
Mm-hmm.
I like it. It's
Now,
busy.
it's very busy, but that's why we isolate them and we do them sort of separately so they look a little different. One of the things we could do, but I don't want to do it because we're a little fried tonight. One fun thing is on this one, right? Once you've got all 9 points, you've created 9 more points on the inside, right? You can see the intersections.
Mhm.
So then you can do another internal Enneagram. So you would, like, if you started down here at this intersection, you would just cross up, skip the F, you would skip H, and you'd go up to A. Essentially, they aren't lettered. But then that would give you another, it would basically be fractalizing in and in and in. And that is a really fun one to do. So if you do decide to draw again, that would be a new way. We would do that right now, but I think, am I right in assessing that we're in a little bit of a brain fry and it would be better to stop where we're stopping? Or we could do it again. But if we were to have the full class, that's where we would keep going next, right? So that's the idea, and that's part of the fun thing for the sort of homework. And if you're following along and you want to have more time, you can darken in these points, right? And then use those as the origin points, and you're skipping every other one, just like you did on the step to make that obtuse hexagon, right? So we would fractalize in there. And I'm going to make sure to draw that one up to have an example.
And how many times do you fractalize it?
As many as you want.
Okay.
Usually it'll lose a little precision, and so it gets a little bit wonky, but go as far as you can.
Okay.
So
So in the future, if we're gonna puncture paper, let me know ahead of time, and I'll take it out of the pad.
Okay.
So I've been keeping everything in the pad so that I have a record of everything I've done in consecutive order. But yeah.
Okay.
'Cause I really would have liked to do that too. But it's just
We will not be puncturing anymore for the remainder of the 3 weeks.
Okay.
That was the last puncture. So
And go back 1 second and just tell me what I did wrong initially with the flower thing, so that I was always cockeyed. Because it happened the last time we did it.
okay, so when we have our first circle, I'll show you. All the way back up. When you've got your first circle, and we don't have a single circle here, but when you do the original single circle, right?
Mhm.
You want to put your compass point at the very vertical bottom.
Okay.
And that'll give you that orientation. And you just started a little bit to the left, right? Which is probably what, because, and I don't end up repeating the steps after a while because I think we've all got the seed, but I didn't mean to assume that that's the thing that threw you off in the beginning.
Okay.
Yeah. And it's, if you pivot your paper, you're still on the vertical, but that would be the thing to pay attention to when you do it next. And tantalizing that idea of fractalizing in, and I'll draw that as well, so we have that on the PDF. So
Okay. Great.
and this is perfect timing because now we're on the 45 mark where you wanted to do that, and so does that sound good
Sounds good.
here?
Yes.
Okay.
Yes, because I can smell dinner and I'm starving and I'll be hangry if we try to draw anything else.
We don't want that. And I think that for me, your flexibility in this and moving with me, and then the, figuring out where the glitches and the nines, and there's kind of a flow and a stop and a start. I feel like there's kind of a larger picture of like being able to like develop that flow muscle, and that kind of surrender of like, it's got to be this way, but when it shows up a little different, to be able to move differently. And I think that level of I think that level of flexibility is like getting really, really vital in like the ascension process, right? Because we just have to let go more and more, like profoundly, in what we think is happening. I mean, I'm sort of speaking to my own life, obviously, but I think there's a meta here, in this class, and how we did it differently this time. Of like it's really easy to bandy about the word surrender, right? But we're talking about like the application of letting go, the way that things make sense. And I don't think things are going to be making sense coming up. So anchoring in the knowledge of like the letting go is what actually makes sense. It's like the only thing that makes sense. So
Absolutely.
that's what I'm going to take from tonight. And I really appreciate you hanging in. I love having classes with you. I so enjoy our time together. And thank you.
Great, thank you.
Yeah.
I do too. I look forward to it. I don't know what I'm going to do when it's all over.
Well, I don't know. Take a crop circle class or something. We'll just keep having fun. Hang on one second. I'm going to wrap up the recording, and then I want to just say one last thing to you.
Sure.
Right.